Bismillahirrahmanirrahim. Hello and very warm welcome to another tutorial which is on pseudo first order kinetic model. Before this we did data fitting in Langmuir adsorption model. Today we will do the kinetic model and we will start with pseudo first order kinetic model. We will use the same data as we used in our previous tutorial. The equation for pseudo first order kinetic model is ln QE minus QT is equal to ln QE minus K1T. QE, as you know, that this is the adsorption capacity at equilibrium. QT is adsorption capacity at time. K1 is the pseudo first order kinetic constant and T is time. We will plot ln QE minus QT versus T. Our T will be on x-axis while our y-axis values will be ln QE minus QT. And from this we will calculate the QE and QT value and K1 value from this equation by plotting these from the slope and intercept. So let's begin. As you know that the equation for calculating QE is C naught minus CE divided by W multiplied by volume. As our volume was 60 ml, so in liter it will be 0.06. Just dividing 60 over 1000, we will get 0.06. And the same, our W, our mass of the adsorbent, was 60, so it will also be equal to 0.06. 60 divided by 1000. Okay, so this is our V and this is our W value. So QE will be equal to C naught minus CT multiplied by volume 0.06 divided by 0.06. Okay, and copy this formula. Copy the formula till the end. So now we have QE value. Okay, the next thing is, when you are doing the kinetic modeling, you have to choose one initial concentration, as these are different initial concentrations, and for every concentration we have QE value. So in our experiment we use 30 milligram per liter for the optimization. For the optimization we only used 30 milligram per liter. So this data we will use in determining the pseudo first order kinetic model. So we run an experiment with different time interval. We know our initial concentration is 30 milligram or 30 ppm, and then we calculated the concentration at time, at 0 minute, at 10 minutes, up to 120 minutes. So this is our CT value, concentration at time. QT we will calculate from this data, C naught minus CT. The formula will be the same. This one, the equation will be, we will have the same equation, QE is equal to C naught minus CT. Instead of CE, concentration and equilibrium, we will have concentration at time multiplied by volume divided by weight. So we will have the same formula is equal to C naught minus CT multiplied by 0.06 divided by 0.06. These values can be different as according to your volume and mass of the adsorbent. So we will drag this till the loss concentration, and this is our QT value. QE value for 30 minutes is 19.238. So we will copy this and paste over here. Drag it till the end. Now QE minus QT. QE minus QT. And copy this till the end. Next is ln QE minus QT is equal to ln natural log of this value, and copy it till the end. So we have ln QE minus QT value, and we have time value. So we will plot this value against the time. Against the time. So let's copy this and plot it in origin. You can plot it over here in Excel or in origin as you wish, but I prefer to plot these values in origin. Take the scatter plot and then go to analysis, fitting, linear fit, and open dialog. After opening dialog, no need to change anything, just press OK. Press OK, and then OK. So this gives us the intercept and slope value. We will copy these values and paste it we'll copy these values and we will paste it over here. We have the intercept is 3.336, while slope is minus 0.02709. Okay, now we will calculate the QE value from here. This is the QE experimental. This one QE we calculated is the experimental adsorption capacity at equilibrium, and this one is our calculated one. So we have the formula that intercept is equal to ln QE, natural logarithm of QE. When we convert this, we'll get QE will be equal to anti-ln or exponent of the intercept. So the formula will be is equal to, just write exp, you get the exponent of the intercept. Select the intercept value and press enter. So this is your calculated QE value, the calculated one. This is the calculated QE value, and this is the experimental, which you get it from the experiment. Okay, when you did the experiment, this is your experimental, and this is your theoretical, or this is your calculated QE value. Now we will calculate the K1. The equation is slope is equal to, for calculating K, slope is equal to K1 into T, while our K1 value or the K value or the pseudo first order kinetic constant is equal to slope divided by time. So we have the slope value, and the time which we will use is the, if we run the experiment for 60 minutes, then we will select 60. But as we are running the experiment up to 120 minutes, so we will select the 121. Whatever the duration of your experiment is, the end point of your time, you will select that time. So it is 120 minutes. For example, if you are running it at 180 minutes, then you will select the 180 minute. If you are doing it for 24 hours, then you will go for 1440 minutes. So as the time is in minutes, so we will select that one. So 120 minutes, and this will be our K1 value. The R square value, we'll get it from here, the adjusted R square 0.84307. So our R square value is 0.84307. Okay, this is our R square value. So this is all about how to plot your data in pseudo first order. You will select only one kinetic model, whether pseudo first order, pseudo second order, first order, second order, or zero order. So it will be based on your R square value. Any model which have more closer R square value, then your adsorption or your reaction is following that kinetic model, that order of reaction. Okay, that order of reaction, it will be based on your R square value. So after this, we will do the pseudo first order, pseudo second order, and second order reaction. So you will use the same data. We'll use the same data, and we will determine that our adsorption experiment is following which one model, which one order of reaction. Okay, so for reporting this, let's go to the graph. You can add text pseudo first order kinetic model. Okay, pseudo first order kinetic model. You can bold these values, increase its size, and increase its size also. You can increase this size also. So your graph may look better. As time is in minutes, so we'll go to our book, and we'll write down its unit. So this may be updated over here. Okay, you can change this thing, just increase. You have the regression equation y is equal to mx plus c, or y is equal to a plus bx. You have the intercept value and you have the slope value, and the R square value is 0.8437. You can keep this, or you can write over here what is your R square value. It depends upon you, what you want. Then copy this as a picture and come to the word pseudo first order kinetic model, figure 1. Pseudo first order kinetic model of whatever your adsorbent is. For example, we have activated carbon. This is caption. Just paste your graph and it will look like this one. Okay. Next is copying the table. Just paste the table over here. Okay. You can make changes. You can make changes in this. And okay, one more thing. This QE is the calculated. You can also add another column and QE experimental. You can add the QE experimental value, which is 19.238, 19.238, and fit it according to the contents. So this is a graph which you will use for reporting your data. Okay. Hopefully now you understand how to do the pseudo first order kinetic model, how to fit your data in pseudo first order kinetic model. This is the equation. Okay, this is the equation, and you will plot ln QE minus QT versus time. You will calculate the ln QE for your experimental data, and then you will get the ln QE minus QT value after calculation. Plot these values. Okay, plot these values in origin or in Excel. I'm doing it and in Excel also. You will do the linear trend line option, display the equation and display the R square value. So it is almost same. The intercept is 3.37, while the slope is minus. The intercept is over here, 3.33, while your slope is 0.027. Okay, you can use this data or you can use the data from the origin. I hope you understand this, and now you can do your, you can arrange your plot according to this. Thank you very much. If you have any question, you can ask in the comment section. And if you need any help in analyzing your data, you can also consult me in the comment section. Hopefully, you will subscribe to my channel, you'll press the bell icon and share it with other students and colleagues. Thank you and Allah Hafiz.